Good evening, guys. This is James Gun tutorial. My name is Liz. On today's video, I'll teach you guys on how to examples on how to solve questions on units and dimensions. Now, I have this question. Question number one says that given that impulse is a product of force and time. Now, you have to do what? Find the dimension of impulse. Now, how to do the solution? You know that impulse simply means the change in momentum, which is equal to force times time. Okay. Now, therefore, impulse equals force times time. Now, as I said before, you know that before you find that dimension of any unit, you have to first find the what the you have to first find the unit of that quantity. Please know that before you find a dimension of any quantity, you have to first find a unit of that quantity first. Okay. Now, therefore, first I have to find a unit of force. Now, force is equals to mass times acceleration, right? Now, we say that force is equals to what? Unit of mass is in kilogram. Now, times unit of acceleration is meter per second square. Now, which is equals what? Kilogram meter per. You know that per simply means division. So this per now this per x square means something like this. Per x square means something like this, means 1 over x square, which is something as, you know that 1 over something in mass means inverse, that is minus, that becomes x raised to power minus 2. So that was how I got kilogram meter s x raised to power minus 2. Okay. Now, therefore, dimension for force is, now you know the dimension in dimension, mass is what is in big M, capital M. Now, meter is in what? Capital L. And seconds is in what? Capital T. So that becomes what? Kilogram is mass, that is big M. Meter is in what? Capital L. And then seconds in capital T. So therefore, this is the what? This is the dimension for force. Now, therefore, what's next? Now, therefore, unit for time is seconds, and therefore dimension for time is t. And therefore, remember that you have to force times time. So that becomes, now my dimension for force was this ml t raised to power minus 2. So that becomes ml t raised to power what? Minus 2 times t. Now, therefore, which is equals to, if you check this now, that becomes ml. If you check this is t raised to power minus 2, and this is t raised to power invisible 1. So this is 3 raised to power invisible 1. So if you do it minus 2 by using your law of indices, so that becomes minus 2 plus 1 is same thing. That's what I did there. T minus 2 plus 1. So that becomes MLT minus 2 plus 1 is what? Is minus 1. So therefore, this is the answer. Very, very simple. Very simple. Now, I have number two. Number two question say that suppose the acceleration A of a particle. Suppose the acceleration A of a particle of particle moving with uniform speed v in a circle of radius r is given as what? A is given as what? They say that suppose that the acceleration A of a particle moving with uniform speed v in a circle of what? Radius r is given as what? A equals what? K raised power k r raised power n v raised power m, where k is a dimensionless constant. Now, you have to do what? Determine the value of n and m. Now, solution to solve this, since they say that A is equal to this, right? Now, therefore, I have to find the unit of all the quantities. Now, therefore, unit of A, which is acceleration, is what? Unit for acceleration is what? Is meter per second square, right? And also this is radius, right? Which is now unit for radius is meter, which is what? M. Now, therefore, units for v, that velocity, is what? Meter per seconds, right? Now, therefore, finding the dimension of all these units becomes what? Now, dimension for acceleration is what? Where m is what? Where meter, the dimension is what? Is capital L. This is per. This is per. That becomes 1 over x squared. That is the same thing as what? X raised to power minus 2. So that becomes, I know that dimension for seconds is what? T raised to power minus 2, right? And then this is radius, which is what? Meter. And the dimension for meter is what? Is a capital L. And this is v, which is what? Which is meter, which is v, which is meter per seconds. I know that the dimension for velocity is what? This is meter. per seconds means 1 over x, which is something as x raised power minus 1, which is something as t raised power minus 1. Okay, now therefore putting all these values in this word equation. Okay, so therefore putting everything where my solution is what, where my solution is this, where my the dimension for my solution is this, and my dimension for radius is this, and then that of velocity is this. Now therefore putting everything here, so that becomes what, dimension for acceleration is what, is equals to what, k is constant bracket, dimension, this is what, dimension for radius is what, is L, which is L raised power what, n times dimension for velocity is what, is L t raised power minus 1, which is bracket raised power what, m. Okay, now therefore that becomes L t raised power minus 2 is equals to k bracket L raised power n times. Now if you multiply this, that becomes m everything here will times by the power of m. If you check here, the power of this L is invisible 1. So if you do it, 1 times m is something as m. So times t. Now m times minus 1 is something as t raised power minus 1. Okay, something t raised power minus m. So that becomes L t minus t is equals to k bracket. Now if we are to collect like terms, that becomes L raised power n times L raised power m. That will give you what? You take one by using a law of indices. You take one base. That becomes what? Times into what? Plus. That becomes n plus 1 times t raised power minus m. Okay, now which is equals to what? We have this L t raised power minus 2 is equals to k bracket L raised power n plus 1 t raised power minus m. So therefore what you do, comparing the both equations, that becomes now comparing for L. Now L is equals to L raised by n plus 1, right? So if L to cancel L, that remains 1 is equal to n plus 1. So therefore that becomes n plus 1 is equals to 1. I call this equation 1. Now therefore comparing for t, I have t raised by minus 2 is equal to t raised by minus n, right? So therefore if t is to cancel out, t remains minus 2 is equals to what? Minus n. So therefore m is equals to 2. Now put m equals to 2 in equation 1. So that becomes n plus m is 2 is equals to what? 1. So that becomes n is equals to what? This move over here, that becomes 1 minus 2 is something as well. So n is equals to minus 1. Now therefore m is equals to 2 and n is equals to minus 1. Now therefore put your answers in this equation. So that becomes a is equals to k r raised power where n is minus 1, v raised power where m is 2. So this is the answer. Very, very simple. Very simple. Now I have number 3. Number 3 question say that the speed v of an object is given by the equation v equals to a t raised power 3 minus bt, where t refers to time. Now what are the dimensions of a and b? Solution: to solve this, you know that v is the speed. Okay, so since v is equal to speed and speed is something as velocity, so that becomes unit for speed is what? Meter per seconds, right? And t is equal to time, therefore unit for time is seconds. Okay, now therefore I have to find the dimension for all these units. Now dimension for speed is what? Where meter is dimension is L. Now and this is per second, which is 1 over which is s minus raised power minus 1. So that becomes, and dimension for seconds is what? Is t, that becomes t raised power minus 1. I know that now that dimension for time is what? Is capital T. So therefore putting all this in the equation, put all this in this word equation. Okay, so that becomes where v is velocity, that becomes velocity, the dimension for velocity is what? L t raised power minus 1 is equals to what? I have a, and dimension for time is what? Is capital T, that is t raised power what? 3. Okay, now minus b bracket dimension for time is capital T. So that becomes what? L t raised power minus 1 is equals to what? If you multiply everything here, that becomes a t raised power 3 minus what? bt. So therefore what do you do? Now therefore what do you do? Okay, now comparing I have to do compare this equation. So if you comparing the equation, now I have to compare the equation, which means that you know that this is equal to this, and also this is equal to what? This. Okay, you understand? It means that this is equal to this, and also this must be equal to this. So that becomes, now taking the first step, L to raised power minus 1 is equals to 8 raised power 3. So that becomes L to raised power minus 1 is equals to 8 raised power 3. So which is what? Now what do? I want to find the dimension for a. So what I do now, I have to do what? Divide by coefficient of a. So if I divide by coefficient of a, that means that I'll divide all through here by t raised power 3. So that becomes LT minus 1 all over t raised power 3, and here by all over t raised power 3. So if you cancel out now, a is equals to what? LT minus 1, LT raised power minus all over t raised power 3, which is equals to what? LUT minus 1 times, you know that if this 3 raised to power 3 move over here is same thing as 3 raised to power minus 3, okay? Because you know that this thing here is same thing as this thing here is same thing as LUT minus 1 times 1 over 3 raised to power 3. I know that 1 over 3 raised to power 3 is same thing as 3 raised to power minus 3. So therefore that becomes equals to LUT raised to power what? Now, if it by lots of indices, that becomes what? Minus 1 minus 3 is same thing as what? Minus 4. So therefore the dimension for A is LUT raised to power minus 4. Now also let's go for the next one. We have LUT raised to power minus 1 is the same thing as BT. So let's start. That becomes we have LUT raised to power minus 1 is equal to BT. So therefore what do I do? I divide all through by coefficient of B. Now the coefficient of B here is T. That becomes divide all through by what? T. Now LUT raised to power minus 1 all over T equals to BT all over T. If T is cancelled, that remains only B. B is also LUT raised to power minus 1 all over what? T. So therefore that becomes B is equals to LUT raised to power minus 1 times, you know that this, if this move over here, that becomes T raised to power minus 1, okay? Because if you check this, there's an invisible one here. So that becomes, now T raised to power minus 1 times T raised to power minus 1 is same thing as what? If LU and collect 1B, that becomes minus 1 minus 2 give you what? Minus 2. So therefore the dimension for A is this, and the dimension for B is what? Is this. Very, very simple. Now I have this question. Question number 4 says that at what respective values of x, y, and z would the unit of force Newton be dimensionally equivalent to what? MOS, LOY, and TZ. Now let's solve this. Solution. You know that force is also mass times acceleration, right? So therefore let's find the unit of force. Unit of force is mass times acceleration, which is what? Now unit for mass is kilogram times unit for acceleration is what? Meter per second square, right? So if you combine this together, that becomes kilogram meter x raised to power minus 2, right? Now therefore let's find the dimension for unit of force. And I know that in dimension, mass is what? Is capital M, meter is capital L, and time is capital T. So this is kilogram, which is mass, capital M. This is meter, which is capital L, and this is second, which is 3 raised to power minus 2. So is it simple? Now I know that F is what? M raised by S, L raised by Y, and T raised by Z. So that becomes where my F is this, that M L 3 raised by 2, right? Is equal to M S, L Y, and T Z. So therefore, what do you do? Now comparing both equations, taking M is equal to M raised by S, right? So if M is to cancel out M, that equals 1 is equals to S. Therefore S is equals to 1. Now take L is equals to L raised by Y, right? So if L is to cancel out L, we have L cancel out itself remains 1 is equals to what? L cancel out here is what? Is Y. So Y is equals to 1. So let's take T. We have T raised by minus 2 is equal to 2 raised by Z, right? And T cancel out T here remains minus 2. T cancel out T here becomes Z. Therefore Z is equals to what? Minus 2. Now therefore X is what? 1, Y is what? 1, and Z is minus 2. Very, very simple. Very simple. Now I have this question, the last question, which is question number 5. It says that Newton's law of gravitation is given by this. Now all times have their usual meanings. Now you have to what? Find the dimension of the dimension of G are what? Now you have to find the dimension of G. I know that this G means what? Means universal gravitational constant, right? So therefore for me to find G now, I have to make G survey formula. So therefore becomes, if I should make G survey formula, G is equals to what? F arrow square over M1 M2. So you know, because if you multiply this, that will give F arrow square is equal to GM1 M2. So divide all through by coefficient of G, which is all through by M1 M2 and M1 M2. So if you cancel out here, G is equals to what? F arrow square M1 M2. Okay, very, very easy. Now therefore after doing that, I have to find the dimension of each of these. Now dimension for force. So I'll find the unit of all these first. Now force is mass times acceleration, right? Now therefore the unit for force is what? Is this. Now therefore this is what my this is radius or what? Distance, and the unit for radius is what? Meter. Therefore arrow squared is meter times m1 times n, which is m square, right? And this is mass 1, and unit for mass is kilogram. This mass 2, unit for mass is same thing as kilogram. So therefore find the dimension for all this. Now dimension for force is what? Kilogram. Mass is capital L, capital M, meter is capital L, second is 3 raised to power minus 2. And we have here dimension for radius. which mu square is what? Lu square. Now, dimension for mu is capital M. The dimension for max is capital M. So therefore, put all these values in this word. Put all these values in this equation. Now, therefore, G is equals to what? Now, dimension for F is what? M Lu to the power minus 2, right? Times what? Times what? What is the dimension for R square is Lu square, right? All over. Now, dimension for mu is mu times dimension for mu is the same thing as that is mass is m. So therefore, what is next? If m was to cancel out, m times m will give you mu square, right? So that becomes m here cancel out mu square, it remains m. So here becomes L that becomes L raised to power 3 t raised to power minus 2 all over what? M. So or if this m goes go up here, that becomes m raised to power minus 1 L raised to power 3 t raised to power minus 2. So this is the final answer. It's very, very simple. Please guys, if you find this video interesting and helpful, please don't forget to like, subscribe, comment, and also share. Please. Thank you.